Good morning, everyone. This is Varma Rajasagi from PonuraOnline.com. I hope all of you have attended already the session by Mr. Abdullah. So basically, I'm also a mechanical engineering graduate from JNTU. I think I've worked post 2003. I've joined with Hindustan Aeronautics Limited at Bangalore, and then I've also worked as a scientist in ISRO, and I appeared for CAT and GATE, got more than 99 percentile, and I joined with SP Jain as a MBA graduate. Post that, I've also worked with Schneider as a global operation head. Because of my passion towards education, I'm associated with Quandura, and basically I take care of all the academics related. I'm the vice president academics in Quandura. I will be taking a lot of sessions on quant and reasoning. And don't hesitate, feel free to ask me in case of any doubts, and make use of chat window. And if you look at people who are joining the platform, you will have three parts. The first part is containing the video, and the second part is the where it is actually ICQ, with what we call as an in-class quiz. So you can start interacting in terms of we will be administering the question. So in case if you can respond to those questions, it is acts like a physical handout in the classroom. And the last part is going to be our chat window, wherein which you can start interacting with me. So don't hesitate, feel free to ask me, and this is the place where you can afford to commit the mistake, but then please see through that you are learning from those mistakes and you are not repeating them as a part of your company's test. So yes, I'm hoping that people who are joining the platform, just say hi. I think we have Aman, we have Emmanuel, we have Aviral, Sriza, Lokesh, Girish, Rishabh, Suvas, Anirudh, Sudeep. A very warm good morning to all of you. Let's quickly start with today's session. The topic of the day is going to be the number systems. I'm going to cover quite a few concepts which are related to numbers, and mostly I will be focusing on the important concepts which are going to get tested in the various companies exams. So today we will be looking at all this as a part of today's sessions. Basic classification. I'm also going to cover the applications of coprimes as well as LCM and SCF, and we'll also be looking at a couple of questions on units digit, reminders, and the highest power of digits. So let's quickly start with the basic concepts. So I want you to stay focused for next 2-3 minutes, which is going to be prima facie. I'm sure all of you are aware, but then the discussion is very important for the subsequent sessions, because you need to be fundamentally aware of all the basic terminology of the numbers, which are very important for the subsequent sessions. I'm sure all of you know how do you classify the numbers. If you look at the numbers primarily classified into real numbers and imaginary numbers. As far as our discussion, we will only focus on real numbers, because imaginary numbers are something they will not be get tested. So let's stay focused on the real number. So anything which is represented on the number line is known as real numbers. In fact, they can be further classified into integers and decimals. I keep asking the fundamental questions. Let me see how many of you can answer. Now integers can be further classified into positive integers and negative integers. Now the first question for all of you is 0 is a positive or negative integer? Keep sharing your answers through chat window. Is 0 is a positive integer or a negative integer? What do you feel? Is 0? So I think I have a lot of students who are already onboarded. Please see through that all of you are responding. Is 0 is going to be zero is going to be positive or negative? In fact, I got yes, Ghosh, I want Manuel says positive, somebody says neither. It is not an integer itself. No, it is of course an integer, Rishabh. It is of course an integer. In fact, yes, Akash, absolutely right. 0 is neither integer, neither positive nor negative. So in fact, 0 is special. 0 is neither positive. Positive integers are only 1, 2, 3 up to infinite. Now negative integers 1, minus 2, minus 3. So please positive nor negative. Now what is non-negative? Non-negative. The moment I say non-negative, most of the people will think of positive. Non-negative does not mean positive. Non-negative means anything other than negative. So if you look at other than negative, I also have 0 and positive. So non-negative does not mean positive. Non-negative integers are popularly known as whole numbers. In fact, positive integers are popularly known as natural numbers. I'm sure all of us know. A quick recap: positive integers are known as natural numbers, non-negative as whole numbers. Non-negatives also 0 is included, then it is known as whole numbers. Now, in fact, integers also can be classified as not only positive and negative, they can also be classified as they can also be classified as even and odd. So if you look at what I've said earlier, recollect, positive means only 1 to infinite, and non-negative means 0 and positive. So anything other than negative, non-negatives are also popularly known as whole numbers. Similarly, what I've said, positive integers are also popularly known as natural numbers. Now, as far as the integers are concerned, they can also be classified as even integers and odd integers. Now, again, a very commonly committed mistake. Now, can you tell me what is going to be the least positive even integer? Least positive even integer. So, most of them say, the moment I say integer, they will, sorry for the inconvenience. The moment I say the least positive integer, most of you are absolutely right. You will only think of 2. Yes, the moment I say even integers, people only think of 2, 4, 6, 8. Yes, absolutely right. But very commonly committed mistake, 0. Yes, 0 is also even integer. In fact, negative integers are also even integers, to minus 2, minus 4, minus 8. So don't think of positives alone. Negative integers are also even. Anything which is divisible by 2 is known as even integer. So don't ever restrict to positive even integers, 2, 4, 6, 8. But 0 is also even integer, and similarly minus 2, minus 4 up to minus infinite. Similarly, as far as odd integers are also concerned, people will only think of 1, 3, 5. But do bear in mind the fact minus 1, minus 3, minus 5, minus 7, all of them are going to be also odd integer. So anything when it is divided by 2 having a remainder 1 is is known as odd integers. So just to summarize, integers can be classified as positive, negative and 0. When I say non-negative, non-negative does not mean positive. Non-negative includes 0 also along with positive integers, and we have also learned the fact integers can be further classified into even or odd. When I say even, anything which is exactly divisible by 2. When I say odd, whenever it is divided by 2 having a remainder 1. But do bear in mind, for negative integer also is going to be either either even or odd integers. Now similarly, if you look at decimals can be further classified into, in fact, let's not get into decimals much at this moment of time. Let's look at the natural numbers in detail. For example, they are also popularly classified into prime and composite numbers. Now, like 0, 1 is neither prime nor composite. Like 0, 1 is going to be neither prime nor composite. Why? Because the reason is very simple. Any prime number has to have two factor 1 and itself. But the moment you take 1, 1 is only having one factor, which is 1 itself. In order to have a prime number, you must have to have two factors, 1 and the number itself. For example, the least prime number we can think of is 2, because 2 has two factors, 1 and 2 itself. And I'm sure you also know the prime numbers below 10, which is going to be 2, 3, 5, 7. And similarly, beyond 10, if you look at 11, 13, 15, 15 is not a prime. You also have 17, 19. If you look at, there are going to be 15 prime numbers below 50, and you must know all these prime numbers. In fact, post session, look at all the prime numbers below 100. You are going to have 25 prime numbers. Again, I am repeating, prime number has to have two factors, 1 and itself. Now, any number has more than two factors, then it is going to be composite number. For example, let's look at 4. 4 has 1, 2 and 4. 3 numbers as a factor. So then this is known as composite number. Let us take 6. 6 has factors 1, 2, 3 and 6. So because it has more than two factors, then it is known as composite numbers. Now, as far as prime numbers are concerned, there is one important concept popularly known as co-primes. Now, can I say 4 and 6 are co-primes to itself? For example, let me write here. Can I say, let me change the question slightly. Can I say 16 and 25 are co-prime to each other? True or false? Let's see how many of you can give me the right choice. I'm opening to all. 16 and 25 are co-prime to each other. Co-prime are co-primes. Simply like 16 and 25 are co-primes. Is 16 and 20 true or false? Now let's see how many of you can tell me. Is 16 and 25 are co-primes? True or false? Please see through that all of you are responding. Pratik says absolutely valid. Now only 1 out of 40 are responding. Please see through that all of you are responding without fail. Yes, some of you says Rishabh says absolutely valid. Good. Now if you look at 16, what are the factors of 16? So can we express 16 as 1 into 16, 2 into 8 and 4 into 4? Any other ways of expressing? No. So these are the factors. What about 25? 25 can be expressed as 1 into 25 and 5 into 5. So if you look at both 16 and 25, the only common factor is 1. The only common factor is 1. We do not have any other common factor. So whenever two numbers do not have any other common factor except 1, then they are popularly known as co-prime. The beauty is neither 16 nor 25 are prime numbers, still they are co-prime to each other. Now let me ask you certain fundamental questions. Is any two prime numbers are co-prime to each other, valid or not valid? I am repeating the statement. Any two prime numbers are always co-prime to each other. For example, take the 2 and 3. They do not have any other common factor except 1 itself. So definitely they are co-primes. Similarly, take 3 and 5, take 3 and 7, take 2 and 7. So you take any two prime numbers, they are always co-primes. But that is not a necessary condition. The beauty is, just now we have learnt 16 and 25, neither of them are prime, still they are co-prime to each other. Now what is the importance of co-primes? There are two major applications of the co-primes. One is going to be divisibility rules and the second is going to be LCM. I'm going to look at little later. Let's summarize the discussion right now on the coprimes. So natural numbers can be classified as prime, composite and unity. Prime numbers are the numbers which have only two factors, 1 and itself, and composite numbers are the numbers which have more than two factors. And if any two numbers do not have any other common factor except 1, then they are said to be prime numbers. Yes, in fact, the only even prime number is going to be 2. So 2 is the only even prime. Other than 2, if you look at any other prime number, they are absolutely going to be odd. For example, 3, 5, 7, 11, 13, 17, 19, all of them are going to be odd. The only even prime number, bear in fact that the only even prime number is only going to be 2. Yes, all of you are absolutely right. Yes, let's quickly look at a couple of basic questions. Let me see how many of you have understood really whatever I'm saying. Now, let me see how many of you can do it. This is the question actually given in TCS last year. Let's see how many of you can do it. A student started writing. In fact, I want you to see, I've already broadcasted this question. Please see through that. You are marking your choices on the ICQ window. In case if you have any doubts, feel free to ask me. I'm giving you absolutely 1 minute. Your time starts now. I'm hoping that by now the question is already being displayed onto your screen. So please look at the question. Look at on your ICQ window. Keep sharing your choices. Yeah, so I'm repeating the question. If you look at a student started writing all the natural numbers side by side. When I say natural numbers, so you should start 1, 2, 3, 4, 5. So he kept on writing 7, 8, 9, 10, 11. Yes, this is what he is saying. 13. So he wrote all the natural numbers up to 180. So if you look at how many single digit numbers are there? How many single digit numbers are there? There are 9 single digit numbers, and then you also have a 2-digit numbers. How many 2-digit numbers are there? Because up to 99 you will have 2-digit numbers, and then post that you will have 100, 101, 102 and keep moving. So these are going to be up to 180. Now all that author is asking, he wrote all the 180 natural numbers and started counting the digits. Find the number of digits he wrote. Find the number of digits he wrote. So because they are single digit, how many numbers we have? 9 single digit. 9 into 1. So definitely 9 digits are available here. And how many 2-digit numbers are there? We are writing from 10 to 99. Which means very commonly we committed mistake to take it as 99 minus 10. There are only 89 numbers, which is wrong because considering the extremities we have to add 1. So very commonly committed mistake. If I ask you how many numbers are there between 11 to 14 including both of them, can we say 14 minus 11 there are only 3 numbers? No, because we have 11, 12, 13, 14. Which means while considering the extremities, if you are taking the difference, then you will be you will only be finding the one number less than the actual number. So that's the same logic here. If you look at between 99 to 10, how many numbers are there? In fact, there are not 89. They are going to be 90 into 2. Why into 2? Because each number consists of how many digits? 2 digits. So how many digits we have here? 90 into 2, 180 digits we are having in 2-digit numbers. Now similarly, if you look at 3-digit numbers, how many 3-digit numbers we have? 180 minus 100 plus 1, because considering the extremities we are adding the 1 into 3. So if you look at, this is going to be obviously, which is going to be how much? 81 into 3, which is absolutely going to be 243. So we have 9 single digit numbers and 92 digit numbers which contributes 180, and 81 3-digit numbers which contributes 243. So together we definitely have 243 plus 9, which is going to be 252 plus 180, which is going to be, yes, 432. So what is the number of digits he wrote? Definitely the right choice is going to be how much? 432. In fact, let me see how many of you given the right choice. In fact, great. Quite a few, more than 50% of absolutely given the right choice, but quite a few of them are also given, close to 20% of the students have given 433. So you need to be a little more careful, because after putting so much of hard work, if you are writing the wrong choice, unnecessarily, not only that we are losing to the competitor, and we are also giving up on the easier questions, which we need to see that we are making on the harder questions. So it's important that we are not losing out on any of the questions which we are known to us, and any of the questions which are, in fact, I keep saying, any competitive exams, if you are not able to attempt the difficult question, you will never be penalized. But the moment if you are able to lose on the easier questions, because you are not only losing on the easier front, and you need to make it up in the harder ones, so which is going to be very difficult. So never ever lose out on the concepts which are easier and which are known to us. Yes, let's move on to the next one. Yeah, now intentionally, let's look at this question. In fact, let me broadcast the question. Let me see how many of you can do it. I've already broadcasted the question. Please see through that. All of you are attempting, and keep sharing your choices. In case if you have any doubts, feel free to ask me. Yes, I'm looking forward to all of your choices. What is the value must be assigned to the given operator symbol or star, so that the number 48657 star is exactly divisible by 24? Yeah, people who are comfortable, please go ahead and answer. Others look at. Before, one of the classic application of coprimes is divisibility rules. Now, for example, let me take this number. Before I discuss, I'm just deviating. For example, 1, 2, 3, 4, 5, 6. Is it divisible by 2? Is it divisible by 2? Yes, I'm asking the question, is it divisible by 2? Because I'm sure all of you know the fact, because the units digit is 6, so definitely it is divisible by 2. Whenever a 2, see, you need to understand any 10 is always divisible by 2, so we are only going to focus on 6. Yes, definitely valid, divisible by 2. Now, is it divisible by 4? Please appreciate any 100 is always divisible by 4, because 425 is 100. I will only be looking at last 2 digits, and 56 is also fortunately divisible, so definitely it is also divisible. Yes, valid. Now, is it divisible by 8? Because any 1000 is always divisible. That is the reason. In fact, you can make a generic rule, if at all, it is also valid. It is also any number which is in the form of 2 power n. The divisibility rule is I should be validating last n digits. If the last n digits are getting divisible by 2 power n, then it is definitely divisible. Now, what is the divisibility rule of 3? If you look at 3 or 9, the rule is very simple. I'm sure all of you know all these fundamentals. I'm quickly recapping. Sum of the digits. What is sum of the given digits? Now, if you look at 1 plus 2 plus 3 plus 4 plus 5 plus 6, so 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 15, and 21. So 21 is divisible by 3. So definitely it is divisible by 3. And 21 is not divisible by 9. So definitely it is not divisible by 9. So the rule is very simple. In case of 3 or 9, the sum of the digits must be divisible by 3 or 9, then only it is divisible. Then we have also learned the fact, any number which is in the form of 2 power n, the divisibility rule is very simple. We need to check for the divisibility of the last n digits. I don't need to really worry about the rest of the digits, because the rule is very simple there. And you also need to understand, whenever you are learning some shortcuts, you also need to see that you are learning the limitations. You also need to understand why it is happening, because any 10 is divisible by 2, any 100 is divisible by 4, any 1000 is always divisible by 8. Then that's the reason we are looking at the last n digits, because I don't need to really verify the rest of the digits. Now, similarly, what is the, yes sir, Nisha says 1. Yes, we will validate. Now, what is the divisibility rule of 11? This divisibility rule of 5, for that matter, divisibility rule of 5. last digit must be either 5 or 0. The reason is very simple, because any 10 is always divisible. So I would only focus on 5. So 5 is not definitely valid. And another important one, divisibility rule of 11. Whenever you are looking at 11, you need to take the sum of the digits in alternate places. So what is 6 plus 4 plus 2? 6 plus 4 plus 2, 12. Similarly, 5 plus 3 plus 1. Sum of the digits in alternate places. So 5 plus 3, 8, 8 plus 3, 1. So the difference in the sum of the digits must be either 0 or multiples of 11. So because it is 3, definitely it is not divisible. Now, most importantly, I want you to understand what is the whether it is divisible by 12, or whether it is divisible by 18, or whether it is divisible by 24. I don't need to really focus on 12. What I need to do, what are the factors of 12? 1 and 12, and 2 and 6, and 3 and 4. Now, whenever you are looking at a pair of factors, you need to see that the pair which are co-prime to each other. I cannot take 2 and 6 because 2 and 6 are not co-primes, because 2 is a factor of it. Similarly, what are the numbers I need to look for 18 in order to be divisible by 18, because 18 can be expressed as 1 and 18, and 2 and 9, 3 and 6. But I cannot take a pair of 3 and 6 because they are not co-primes. So I have to consider 2 and 9. Similarly, when you look at 24, can be expressed as 1 and 24, or 2 and 12, or I can express as 3 into 8, or I can express as 4 into 6. But I cannot take 2 and 12. I cannot take 4 and 6, because 2 itself is a factor for in both the cases. I need to take a pair which is 3 and 8, which is 3 and 8. So that is the one of the most important applications of co-primes is going to be divisibility rule. So whether a number is divisible by 12, I need to consider 3 and 4 because they are co-primes. Similarly, whether a number is divisible by 18 or not, I have to look for 2 and 9. Similarly, whenever a number is divisible by 24, I have to look for 3 and 8, but I cannot take 4 and 6 because they are not co-primes. So you need to take a pair of factors which are co-prime to each other rather than any pair, which is very important. So now, as far as this question, that is the logic we should be looking at in order to divisible by 24. So what are the two numbers I have to consider? 3 and 8. Once you know, it's very simple, 3 and 8. Now the moment I know it is 8, so what are the possibilities I need to focus, because the given number is 8, 6, 4, 8, 6, 5, 7, star 2. The divisibility of 8 is the last 3 digits. So 7 not 2. Let me look at 7 not 2, because the possible values I'm taking 7, stay star becomes 0. What will happen? Star becomes 0, because I have a lot of possibilities. It can be 0 or it can be 1, 2, 3, 4, 5, 6. So 8, 7, 8, 9. There are 10 possibilities. Now let's understand one of them. So 7 not 2. If it is 8, 8, 8 is a 64. 64 is possible, but then 62 is not divisible. So 0 is not possible. Now 7, 12. So definitely 8, 8 is a 64. 64, which means 32. Definitely 8, 4 is there. So yes, 1 is possible. The moment I figure out 1 is possible, because next number 7, 12, again I know additionally 50, 40, because 8 5s are 40. 7, 52 is possible. Again additionally 40. So I know there are only 3 possibilities, 1, 5 or 9. So the only 3 possibilities star can take 1, 5 or 9. So let's look at the numbers. 8, 4, 4, 4 8, 6, 5, 7, 1, 2, or it could be 4, 8, 6, 5, 7, 5, 2, or it could also be 4, 8, 6, 5, 7, 5, 9, 2. But the problem is not completed because I'm only verified for 8. It also need to be validated with 3. So let's look at the sum of the digits. So if you look at excluding this, 4 plus 8, 12, 12 plus 6, 18, 18 plus 5, 17, 17 plus 7, 24, 24 plus 2, 26. So 26 plus star is going to be 1. Yes, valid choice. This is definitely valid choice. Now what about if 26 plus 26 plus 5, 26 plus 5, yeah, so 26 plus 5, 31, not possible. 26 plus 9, 35, not possible. So 26 plus 9, 37, 37, 35 or 30, 35, sorry. Yeah, not possible. 35 is not divisible because only 27 is divisible. So the only option is going to be the first option. Yes, I hope all of you are clear. One of the classic applications is going to go prime. So divisibility rules look at 2 or anything which is in the form of 2 power n, it should be last n digits. For 3 or 9, it should be, no, some of the digits must be divisible by them. If it is a 5, you need to look at the units digit is going to be 5 or 0. If you are looking at the 11, the sum of the digits and the difference of the sum of the digits in the alternate places must be either 0 or multiples of 11. The last thing we have learned is in order to find the divisibility rule of any of the composite number, you need to take a pair of factors which are co-prime to each other. Yes, all of you are absolutely right. So let's move on to another question for all of you. Let's see how many of you can do it. Something similar, so I need not explain much, but let's see how many of you can give me the right choice. I've already broadcasted the next question. Feel free to ask me in case if you have any doubts. If you are thorough, we will move on to the next concept. Let's quickly look at the question. Yes, all of you are absolutely right. Vishal, Nisha, Sanchita, Girish, Anbita, Himanshu, Girish, Rita Singh, Anirudh. Yes, all of you are absolutely right. Let's look at a couple of few more concepts because I'm sure till now whatever I've discussed is absolutely simple and I'm sure you are already aware of them. Let's try to get into the little more advanced concept, but before I build on the advanced concept, one must be thorough in all the fundamental concepts. That is the reason I make sure that we are good at fundamentals. So the simple question, I hope by now you started marking the choices. So let me see how many of you have actually done. So if you look at the previous question, yes, more than 50% have given absolutely right answer. Now let's see how many of you have done. That's good thing a couple of you. Most of you given as 4. Divisible by 36, immediately you need to understand 1 into 36, or I can also take 2 into 18, I can also take 3 into 12, or I can take 4 into 9, I can take 6 into 6. But this cannot be co-primes, not co-primes, so the only number possible is going to be 4 and 9. So in order to divisible by 4 and 9, in order to divisible by 4, let's look at 4. Last 2 digits. So immediately I know the fact the value of y should be, because 52 is divisible or 56 is divisible. There are two possibilities. Either it has to be 2 or 6, because no other possibility. 52, 56. Now fine, in both the cases let me figure out y. In order to sum of the digits, so if you look at 1 plus 4, 5, 10, 16, 25, 33, 33 plus 4, 37, 37 plus 5, 43, 43 plus 2, 45. So 45 plus x is one possibility, and in this case again 5, 10, 16, 25, 33, 37, 42, 42 plus 6, 48. Something wrong. 5, 10, 16, 25, 33, 37, 37 plus 5, 42 plus 2, 4. So this is 44 plus 6. Or let me write 44 plus 6 and this is 48 plus 6. In order to divisible by 9, because some of the digits must be 9, so x can take either 1, x can take either 1, sorry, x can take either 1 because 45 is definitely valid. If x is taking a 9, no other possibilities. Now similarly in this case, if you look at x can take, because no other possibility, if x is 2, for example, if x is equal to 2, then it becomes 46, x is equal to 3, 47. So the only possibility after 45 is going to be 54. In order to become 54, x must be 10, the next possibility. Obviously it has to be plus 9, but then x cannot take 10, so definitely not a feasible option. So the only feasible option is going to be x is equal to 1. Now similarly, x can take 6. The next feasibility will be 6 plus 9, x is equal to 15. But again, definitely not a feasible option. So if you look at when x is equal to 1 and x is equal to 1, y is equal to how much? 2. When x is equal to 6, y is equal to how much? Y is equal to 6. So what are the possible values? So x plus y is going to be 3 in the first case, 3 in the first case, and in the second case x plus y is equal to how much? 12. So the right option is going to be either it is going to be 3 or 12, which is going to be absolutely, the fourth option is going to be the right choice. But yes, quite a few of them have also given, yeah, more than 50% is given absolutely right, but then quite a few of them have also given 4 as the second option as the right choice, which is something wrong. Please look at, very few of them are given the first option, which is also wrong, because whenever you have both the possibilities, you need to be a little more careful. So one of the possibility when y being 2 is going to be definitely 3. Similarly, when y being 6, the other possibility is going to be not 12. So you need to be very careful. You need to be able to exhaustively think of all the possible options before you narrow down to the right choice. I hope all of you are able to understand how they are going to get tested. So we know the concepts. The beauty of the competitive exams, you know the concept, you know how to approach, but then still we tend to commit, that is being purely because lack of practice. That is where Conuro Online is going to help you. So please see through that. You are not limiting to the classroom discussion. Post class, I want you to make sure that you are referring the videos and start practicing the questions in the polls, which is going to help you in avoiding such kind of mistakes, and then the chances of success is going to be much higher. So once you start practicing, there is no substitution for practice other than, and even though you are smart, I keep saying it's a fact that people who are going to practice are going to get definitely benefited. Yes. Now let's move on to the next question. Simple. Let's come back to this question little later. Yeah, I'll come back to this. Give me a second. I'm sure all of us know what is LCM and what is SCM. I'm not getting into delve into the much deep into them, but just cursor to what is LCM and what is SCF quickly. I'm sure if you're looking at 2 and 3, what are the factors of 2 and 3? What are the multiples of 2? So if you look at 2, multiples are going to be 2, 4, 6, 8, 10, 14, probably, yes, keep moving. If you look at 3, 3 is going to be 6, 9, 12, and 15, 18, keeps moving. So if you look at what is the least common factor, what is the first least common? 6. What is the next least common factor? 12. What is the next least common factor? One of the important thing, the multiples also takes multiples of it. So if you look at the beauty is the least common factor is being 6. The next least common factor will be 6 into 2. The next least common factor will be 6 into 3. So one of the important observation, common multiples also take multiples of it. So yes, I am sure all of you know the least common factor is going to be LCM of 8, but then the next least common multiple will also be the multiples of 8. So if it is 6, it is the next number is going to be take the multiples of 8. Yes. Similarly, what is the highest common factor? What is the highest common factor? Highest common factor. For example, let's say you have been given 12 and 18. 18. What are the factors? So if you look at 2 and 6, 3 and 4, and if you look at 18, we can express as 1 and 18, 2 and 9, 3 and 6. Yeah, but then if you look at what is the highest common factor, so 6 is the highest common factor. So 6 is the highest common factor. So LCM is the least common multiple of it, least common multiple of it, least common multiple, and whereas HCF is highest common factor, HCS, and people also call as GCD, greatest common divisor, both of them, but most popularly you will find as highest common factor. But normally I don't waste my energies in calculating like this. For example, I want you to spend next 2 minutes in looking at how to do in a much better fashion. For example, what is the LCM of 2, 3, 4, 5? One of the ways is divisional method. I'm sure you will start dividing such that there are no factors to 1. The 3 is not divisible, so you are going to write 3, 2 2s and 5 you are. So there are no so you will take that because there is no number which will divide at least 2 of them here. So if you look at 2 3s are 6, 6 2s are 12, 12 5s are how much? 60. Now the same thing, if you are taking the benefit of the co-primes, now look at, can I say, first I can eliminate 2 because for any fact multiple of 4 is also multiple of 2. So because 2 is a factor of 4, 2 is a factor of 4, I don't need to really consider 2. Look at 3, 4, 5. The beauty is all 3 of them are co-primes because they don't have any other common factor. Whenever they are co-primes, LCM is going to be simply the product of them. So here I don't need to do anything. LCM is going to be simply 2, 3 into 4 into 5, which is exactly going to be 16. Yes, especially for smaller numbers, I'm going to take the benefit of co-primes. I don't need to really calculate anything because no, that allows you to start thinking in the mind rather than making use of a book and or any other external gadgets. So whenever you are looking for a co-primes, the LCM of co-primes is always going to be the product of the given numbers rather than doing anything. For example, if you are required to calculate 2, 3, 4, 5, 6, what is the LCM? I'll not consider 2 and 3 because 6 is already there. Between 4 and 6 they are not co-primes. So what is the LCM? Because the least common multiple is 12. So 12 and 5, because they are co-primes, the LCM is going to be simply 60. I don't need to do anything. 60 is still going to be the LCM of the given numbers because I am taking the benefit of co-primes. Yes. So whenever prime numbers they keep, for example, you are required to calculate the LCM of 4, 5, 6, 7. If I were you, I'll keep 5 and 7 aside because they are prime numbers which are going to be anyhow co-primes to other numbers. Between 4 and 6, 12 is going to be the LCM. So 5 into 7 into 12. So I definitely know because they are co-primes, the product is going to be 420 is going to be my LCM. LCM. So you need to learn the benefit of, you need to learn how to take the advantage of the co-primes. So one of the ways of definitely is going to be LCM co-primes. Another application we have already seen the divisibility rules, and another classic application is going to be LCM. So let's look at a couple of questions how they are going to get tested. Now look at this question. Let me see how many of you can do it. I've already broadcasted the question. Feel free to ask me in case if you have. And if you have already done, I'm also going to shoot another 2 questions in based on LCM and HCF. Feel free to ask me in case if you have any doubts. Yes, I'm giving you absolutely 1 minute. Please see through that. All of you are attempting without fail. Yes, I hope all of you have answered this question. In fact, let me see how many of you have given the absolutely right option. Yes, very few attempts, but I want you to see that definitely you are attempting without fail, because these are all these questions are compilation of the previous uh, company's test. So please make sure that you are attempting without fail. In case of any doubts, feel free to ask me. So yes, some of you are saying 72, some of you are saying 21, some of you are saying, I think I'm getting all the possible choices. Now you need to be very careful in understanding the question. How many of them are multiples of 3 or 7 are there in the first 150 natural numbers? Now very simple. Now if you look at the natural numbers, 1, 2, 3 up to 150. Yes. How many of them are multiples of 3? So for if you look at 3, 6, 9 up to 150, which means I can definitely say there are, in fact I'm surprised. Some of you are giving 7. So 150 by 3, which is going to be 50 multiples. There are 50 multiples which are going to be absolutely multiples of 3. Now, how many multiples of 7? So, if you look at 7, 14, 21, 28 up to 149, 147. So, if you look at 147 by 7, which is going to be 21. 21. So, it seems that there are 50 multiples of 3, 21 multiples of 7, 21 multiples of 7. Immediately people jump into the conclusion 71. But there is a catch here. What are the multiples of both 3 and 7? For example, 21. What is the LCM of 3 and 7? The beauty is because they are coprimes, I can directly take the LCM as 3 into 7, which is 21. On how many multiples of 21? Because 21, 42, if you look at 147 is also multiple. So if you look at how many multiples are there, 7 multiples are there. So you need to appreciate the fact 21 is also counted here, 21 is also counted here. So which means what I am doing, because I cannot take that same number again and again, there are 30 multiples of 50 multiples of 3, there are 21 multiples of 7. So it is like a Venn diagram. There are 3 multiples of 3, 7. If you look at 3, how many of them are there? 50 are there. 7, how many of them are there? 21 are them. But how many of them are common? 7 of them are common. So you need to subtract these 7 which are counted twice. So 71 minus 7, which is going to be absolutely how much? I think 65 or 64. 64, yes. So the right choice is absolutely going to be 64 among the given choices. Yes. In fact, to my surprise, quite a few of them have given the first option, which means again I'm cautioning you, we cannot afford to commit this fundamental mistakes on such kind of questions because they are very easy to approach and we should not lose out on such questions. Yes, absolutely the right option is going to be 64. Neither 72 nor 51 is either of them are wrong. Now one more applications of LCM. Let's see how many if we can do it. I've already broadcasted this question. Please see through that you are spending 30 minutes to understand, 30 minutes to solve, 1 minute. We should be able to answer this question. Yeah, feel free to ask me in case if you don't understand any of the concepts, because I'm moving on to the subsequently on the units visit and reminders and powers, highest power. So all these are definitely of slightly higher level. So please see through that you are paying attention. Now as far as this question, again a classic case of LCM. The moment you read the question, you should be able to understand what exactly R is asking, because nobody is going to ask you what is the LCM of going to be 48, 72 and 108. Rather, they are going to give you the applications which we need to get familiarized. Now, if you look at, sorry, yeah, traffic lights are going to change for every 48 seconds, 72 seconds and 108 seconds. If all of them are changing at 820, again then they will change simultaneously at what time? So if you look at 48, 72, 108, multiple ways of doing. So if you look at, I can see 12 fours, 12 fours, 12 6 and 12 9s. So 12 is common. So let's keep the 12 aside. So we are having 4, 6 and 9. Yes. Now if you look at 4 and 6, again LCM is going to be how much? 4 and 6. So 4 and 6, the LCM is going to be 12. And 9 and 12 are coprimes. I can definitely say, no, 9 and 12 are not coprimes. Again, 9 and 12, 3 is common. So let's keep 3 outside, 4. So basically what is going to happen? 12 is there common. 4 and 6, if you look at 12, so 3 4s are 3 3s are, so it's going to be 36. 12 into 36, which is going to be how much? 72, 7, so 430. Yes, 432 seconds. I'm sure most of you are going with a fundamental way of looking at LCM. So I'm sure, let me explain, which is also very common in most of your cases. 224s, 236, 254s, again 212s, 218s, 227s. If you look at again 3, 3 4s, 3 6s, 3 9s, again I can see 3, 3 4s, because not divisible, 3 2s, 3 3s, again 2 is common, so 2 2s, 2 1s, 3s, no other common factors. If you look at 2 into 2, 4, 12, 36, 72, 144, 144 into 3, which is also going to be 432. So whatever fashion you calculate, it is absolutely up to you, but then I do make use of coprimes, which will reduce the time for calculating the LCM. So the moment you realize LCM is 436, 432 seconds, because 432 seconds, can we express when you divide with 60, 67, how much? 420 and the balance 12. So can we say 420 plus 12 seconds, which also can be expressed as 7 minutes 12 seconds. So because all of them are changing simultaneously 8 hour 20 minutes, after, again it is going to be after 7 minutes 12 seconds, which is going to be 27 minutes 12 seconds. So definitely the right choice is going to be the first option. Yes, I hope all of you have done. Yes, quite a few of them have given absolutely right choice. So I'm hoping that all of you are able to follow. In case if you have any doubts, feel free to ask me. For the people who did not understand, you need to have a discussion with your friends so that in case they will be able to help you, and in case they are not able to help, please never hesitate, keep asking, keep sharing your questions through mail or chat, which will be answered definitely within 48 hours. Yes, now let's move on to the next one. Let me see how many of you can do it. I have not broadcasted the question, but I want you to make sure that you are answering and sharing for the chat window. Let me see how many of you can do it. Find the minimum. I'm sure, and in fact, I'm going to open challenge. People know how to do it. People know what to do it, and they will absolutely 50% of the people still commit the mistake because they will not read the question carefully. So I'm throwing the question. I'm still giving you 1 minute. Let me see how many can do it. Feel free to ask me in case if you have any doubts, but let's see that we are moving on. Let's see that we are marking definitely the right option and take it as a challenger. How many number of shelves are required to arrange 90 mathematics, 135 physics, and 195 chemistry books? such that each shelf contains equal number of books of same subject. And please do make sure that you are making use of your chart window. If you have already done, what is going to be the right choice? Yes, I see a couple of options. Somandri says 15 number of cells. Okay, but read the question very carefully. That's what I'm saying. Sanchita also says 15, but please make sure that all of you are reading the question carefully. Minimum number of shells are required to arrange 90 maths and 135 physics and 195 chemistry. So yes, I see a couple of more options. Rishabh says 15. Unfortunately, I believe that's not a right choice, but let's look at 135 and 195. One of the ways, yes, let's look at only the common factor, because I'm looking for 518s, 527s, 5 threes are 15, 5 39s. Again, I see the common value 3 6s, 3 9s, 3 13. So because they are co-primes, because I'm looking for the highest common factor, 5 into 3, which is going to be 15. But very commonly come to a mistake. I see a lot of people are marking 15, which means you are not paying the attention. The question is not about how many books can be placed in a shelf. The question is how many shelves are required. Minimum shelf I have to place 15 books. So if you look at, in order to place 90 marks, how many shelves are required? 90 by 15, 6 shelves are required. In case of physics, 135 by 15, which is going to be 9 shelves are required. In case of 195 by 15, which is going to be 19, 13 shelves are required. It should be definitely what is the right choice. Yeah, 28 is absolutely right choice. Yes, yes, all of you are right. As far as the previous question, any simple way, previous question, you need to figure out the LCM, whether you figure out using the factors, whether you need to figure out the factors or co-primes. Yes, the only way of reducing the time for this question, especially Rakshita, as far as your question is concerned, I'll make use of the co-primes, then it might reduce the time. But other than that, there is no other way of solving. Either you need to make use of co-primes or you need to make use of factors. Yes, let's not spend too much of time. Let's focus on units digit. I'm sure all of you know how do you calculate the units digit. Now, let me give some questions thereby. Now, look at this question, fundamental question, and give me your option. You don't need to really know the concept, but still you can do certain basic questions, but then we'll increase the difficulty of level of the questions after a while. So all that I know is definitely, if you look at 5924, because I'm focused on units digit. So because the last two digits only, last digits in the unit place only, I'll focus 4 into 9, which is absolutely going to be 36, which means because I'm really interested in units place, so it has to be 6. I don't need to really there is no rocket science here. It's very simple. 6. Yes, 6 is the absolutely right answer. Is it in this tens place? So because most of the cases you will find the units digit is a popular concept. So yes, very simple. But this is Now look at the next one, which is also very simple. In fact, let me broadcast. So in this case also, what will you do? What are the units digit in this question? If you look at, in fact, let me broadcast it so you can keep answering. What is going to be the units digit here? So I've already broadcasted it so that you can see. In fact, I've also broadcast one more question. Find the units digit. Find the units digit. I'm looking forward to all of your choices. It should not take really so much of time. I see yes, 8. Some of you are saying 6 is absolutely right answer as far as the previous question is concerned. But I'm looking for this question. So if you look at it, focus on the units place. 4 into 1, 4. 4 into 9. Now 4 into 9, how much? 36. So 6. So now again, what is that I'm left over? 6 into 8. So how much is going to be? 48. So yes, as far as this question is concerned, all of you are absolutely right. 8 is the absolutely right option. We don't need to be really masters because we are looking at units. Digits in the units place has to be multiplied. Yes. Now this is fine because they are fundamental question. Now look at this. I've already broadcasted this. Yes, all of you are absolutely right. Dibyo, Akash, Vishal, Rakshita, Anirudh. Yes, 8 is absolutely right option. Let's move on to the next one. I want you to be focusing on the next question. Please make sure that you are responding without fail. If the units digit of in the product is 2, so now what is that I've done? I've asked you to calculate the digit here in order to get a units digit of 2. So all I'm saying, so take the units numbers and the units digit. 1 into 3 into star, which is what I need to calculate, into 8 is 2 units digit. So if you look at 1 into 3, 3 into 8, 4. 24. So let's only take 3 into 4 into star, has to be 2. Now 4 into 3 will also be the 2. 4 into 8, then make use of the choices. 4 into 4, not possible. 4 into 3, definitely possible. 4 into 8, 32, which is also possible. This is not possible, this is also not possible. So the only possible choice is going to be definitely either 3 or 8. So what is going to be the right choice? Absolutely, all of you are absolutely right, 3 or 8. So they are very simple. Now look at this. This is going to be interesting. This is going to be definitely typical one. Let me see how many can do it. Yeah, it needs a little bit of knowledge here. Look at. In fact, let me broadcast. People who are comfortable, you can try out. Others, please stay focused. Others, please stay focused. I've already broadcasted this question. Before I get into here, that is where I want you to understand the concept here. Look at, for 1 or 0 or 5, sorry, 0 or 1, let me put it in 5 or 6. The units digit is always going to be irrespective of the powers, 1 power n, 5 power n, 6 power n, it is always going to be the same numbers. For example, 5 power 20, 5 power 1, 5. What is 5 power 2? 25, 5. It is also 5 because I am looking at units. 5 power 3, 125, which is also 5. 5 power 4, 125. So I don't need to really do anything. Similarly, 6 power 1, 6, 6 power 2, 36, which is also 6. So in case of 0, 1, 5, 6, irrespective of the powers, the numbers are always going to be the same. Yes, that's the first thing. Now similarly, in case of 4 or 9, you need to focus whether it is an odd power or even power. If it is an odd power or even power. For example, look at What is 4 power 1? 4. 4 power 2, 16. 4 power 3, 64. 4 power 4. Observe very carefully, pretty much. Whenever it is odd, 4, it is ending with 4. Whenever it is even, it is always ending with 6. So, whenever it is odd, it is going to be 4, even, it is 6. The same way, look at 9, 9 power 1, 9, 9 power 2, 81, which is 1, which is 1. 9 power 3, 729, which is again 1. 9 power 4, 6561, which is again 1. So, again 9 are 1. Now, so if you look at, in case of 9, it depends on whether it is odd or even. If it is odd, which is going to be 9. If it is even, 1. Similarly, in case of 4, if it is odd, 4. Even, 6. Now, what are the numbers we are left over? Let's try to summarize. So, what are the numbers we have left over? 2, 3, 7, 8. 2, 3, 7, 8. Yes. Now, look at very carefully. These are the numbers we are left over. Now, let's try to understand them also. Because every number has a certain pattern associated to it. Look at very carefully. 2 power 1, how much? 2. 2 power 3. 2 power 2, 4. 2 power 3, 8. 2 power 4, 16. 2 power 5, 2 power 5, 32. 2 power 6, 64. 2 power 7, 128. 2 power 8, 256. I don't need to by heart all these values. You need to understand when it is powers. I am writing the powers here. So if you look at 2, 2 into 2, 4, 4 into 3, 4 into 2, 8, 8 into 2, 6. Again, it repeats. Look at 2, 4, 8, 6. 2, 4, 8, 6. The cycle repeats for every fourth power. Similarly, when you look at 3, it is going to be 3. 3 3s are 9. 9 3s are 7. 7 3s are 1. And again, it's going to be 3 9 7 1. 3 9. Similarly, if you look at 7, 7 7s are 9. 49. But again, I'm looking at units digit. 9 9 7 the 3. 3 7 the 1. Again, it's going to be 7 9 3 1. 7 9 3 1. So the cycle continuously repeats. 8 8 8 is a 64. 4 4 8 is a 32. 2 2 8 is a 6. Again 6 8 is a. So the beauty is you have the cycle for every number. In case of 0 1 5 6, I don't need to do anything. They are absolutely the same. In case of 4 or 9, I'm going to focus whether they are odd or even accordingly. In case of the rest of the 4 numbers, 2 3 7 8, I am going to look at the cyclicity of the number. Yes, so now how do I look at applying them? If you are smart here, I don't need to really do anything because here, sorry, look at the question. 5 power, because it definitely will have 5 power 5, not 5, and 6 power 6, not 6. Now look at, you need to be smart. 5 power anything will be how much? 5. 6 power anything will be how much? 6. 5 into 6 will be how much? 0. So once 0 is comes, units digit will be definitely 0. So the right option in this case is you need to understand, because 5 and 6 are there, they are absolutely going to take, irrespective of the powers, they are going to be 5 and 6, because their unit digits product is going to be 0. 0 into anything will always be 0. So definitely their units digit is going to be how much? 0. So the right option in this case is going to be 0. So I don't need to really do anything. In fact, let me see how many of you gives the right choice. Quite a few of them given absolutely right choice. That's quite interesting. Now let's look. So units digit, I've already broadcasted this question for a what is the units digit of this expression? So in this case, I don't need to really waste my energies, because irrespective of these values, I need to focus on 423. So, but we know the 3 cycle. So let's write the 3 cycle. then and there we can write it. You don't need to by heart any of the values. 3 3 3 3 3 are 9, 9 3 are 7, 7 3 are 1 again. So the cycle is very simple. For every fourth power the cycle repeats. Now so if you look at 3 power 423, I don't need to really waste my energies 1, 2, 3, 4 calculating, because any can we express this 423 divided with 4? Can I say 4 no 105, which is going to be 420 and remainder 3. So 1, 2, 3, 4, one cycle. So I have what I'm saying, can we express this 4 into 105 plus 3? All I'm saying, there are 105 cycles, like 1, 2, 3, 4. Again 1, 2, 3, 4, 1, 2, 3, 4. So how many such cycles are there? Because every cycle the same, it repeats. So I don't need to really focus on all this numbers. All I need to there focus is, because it is not going to add any value, it's definitely going to be 3 power 3, which is going to be definitely how much? 7. So the remainder is absolutely, sorry, the units digit is going to be absolutely going to be how much? 7. This is where most of the people will confuse why I'm dividing with 4. Very simple, because every fourth power the cycle is going to repeat the same. So I'm dividing with 4 and I'm keeping those cycles which are not going to add any value to us. Because whether it is, now you need to appreciate the fact, whether it is 3 power 3, whether it is 3 power 7, whether it is 3 power 11, 3 power 15, all of them are going to having the same units, because the cycle is keeps adding with 4. The same thing here, because every fourth power is same. So we are dividing with 4. So 3 power 400 is again cycle starts fresh. 3 power 404 cycle starts fresh. So what is that we are really left over? 3 values. So definitely 1, 2, 3. So 7 is going to be the right choice. Now one more question. So to get a comfort, yes, I've already broadcasted. In case if you have any doubts, feel free to ask me. Yeah. In fact, the previous question, quite a few of them have given absolutely right choice. That's quite encouraging. But very few of them are giving other kind of answers. But yes, Ghosh, don't worry. I'm going to repeat as part of this question. So please try to focus on this question. In case if you still did not understand, feel free to ask me. Yeah, please see through that. All of you are responding without fail. Yeah, again, I don't need to really worry about all this, because beyond 100, because every 100 is divisible by 4. If I were you, I would not even waste my energies. I will directly come to which is as good as 2 power 67, because anything beyond 100, always the 4 divisible by 4. So you will always focus on last 2 digits. You need to be very clear here. Now again, in case of 67, I'll divide with 4, because for 2, the cycle, remember the cycle, because for 2 power 1, 2, 2 power 2, how much? 2 into 2, 4. 2 power 3, how much? 4 into 2, 8. 2 power 4, how much? 8 into 2, 16. 5, again it's going to be 2, because for every fourth power, the cycle repeats. So that's the reason I'm dividing it 4. Can we say 4 16s, how much? 64. What is the remainder? So can we express this as 4 into 16 plus 3? So all I know is this absolutely 16 cycles, and I'm left with what is the here power here 3. So 2 power 3, which is absolutely going to be the required value, is how much? 4. In fact, I am assuming that all of you have done absolutely right as far as this question, because I've been giving a lot of examples in units that one should be familiarizing by now. Yes, I see a couple of you still marking as 4, which you need to be very careful. Some of you still answer. Viha, give me phone. Viha. సో వీడియో స్టాప్ అయింది, ఒకసారి చూడరా ఎందుకు? వీడియో స్టాప్ అయింది అంటున్నారు వాళ్ళు స్టూడెంట్స్. మీది వస్తుందో లేదో చూస్తారు కదా. అంటే ఆటోమేటిక్గా రివర్స్ అయింది వచ్చేది నెట్ టైం వస్తున్నాను. ఓకే, కంటిన్యూ చేయమంటారు కదా. ఓకే, థ్యాంక్ యూ. Yeah, I hope now everyone just refresh the video. Now everybody is able to see there was a slight net connectivity lag in the net which has resulted this failure. Yeah, I'll repeat, don't worry. I'll just quickly repeat here. So all I'm saying as far as this question is concerned, I don't need to really worry about 1, 2, 3, 4, 5 because any 100 is definitely divisible by 4, whether it is 100 or 200 or 300. So it is immaterial. It is always divisible. So what I'm saying, if I were you, I would directly get into 2 power 61, 7 because 1, 2, 3, 4, 500 plus 67 because this is definitely divisible by 100. So all I'm focusing on is 67. So when you are dividing 67 with 4, 4 16s 64 and you will be left over with 3. So if you look at, can we express this as 2 power 67 as 2 power 64? 4, 81, 3 power 5, 243. So the cycle repeats for every fourth power. That is the reason we are dividing it 4. So definitely it is going to be 3 power 3, which is 7. Which is 7. Yes, I hope all of you know again. I think just refresh the video if somebody is having the lag in the internet connectivity. I'm sure it should be back again. రాజు గారు చెప్పండి. సార్ ఓకే. నెక్స్ట్ వార్నింగ్ వస్తున్నాయండి, నెక్స్ట్ డౌన్ అయిపోతుంది మధ్యలో. ఇప్పుడు బాగానే ఉంది మళ్ళీ. సరేలే చూద్దాం. ఇట్లా విల్ కంటిన్యూ అండ్ విల్ సీ ఆఫ్టర్ ద క్లాస్. యా, I think there was some. I'll see that this is not recurring during the next session. Let's focus on the concepts. Now I'm giving you one more question. Let me see how many of you can do it. Please see through that. All of you are attempting without fail. I've already marked the question. Yes, I've already broadcasted the question. I'm sure everyone should be able to do it this time. What are the right choice? Then we'll move forward to the next concept and the last concept for the day. Yes, find the units digit of 13 power 145. So immediately, if I were you, instead of 13 power 145, what I will do is, please stay focused for the next 5 minutes. I'm not going to extend beyond 12:45 because that's the last and important concept on reminder. So stay focused for next 10 minutes. We'll stop here. Now focus on this question. If you look at 13 power 45, if I were you, immediately what I will do, I'll write as 3 power 45. The reason is simple. I'm not really concerned about any digits in the apart from the units digits. Similarly, any 100 is not any 100 is not important for me. So can we say this is 3 power 45 as 4 into 11 plus 1? 4 into 11 plus 1, or all I'm saying is 3 power 44 plus 1. So which is going to be obviously 3 power 1, which is going to be 3. So because we know the fact 3 power 1, 3, 3 power 2, 9, 3 power 3, 7, 3 power 4, 1. So definitely it's going to be how much? In this case 3 power 1, 3. So absolutely the right option is going to be 3. So the first option is going to be absolutely right. In fact, quite a few have given, in fact more than 80% have given absolutely right. So I'm moving on to the next concept, the last concept for the day. Please see through that. You are stay focused. Very important and very simple. Let me start with the question and then I'll discuss how it is done in a much better fashion. So I've already given the question. Let's see how many of you can do it. It should not really take much of your time because unless you are not aware of the remainder theorem. Remainder theorem is very popular as far as competitive exams are concerned. In this case, most of the cases, what students do, they will calculate, they will multiply and divide with 125, which is a foolish way of doing. Rather, the beauty of the remainder theorem is, instead of calculating the products, calculate the individual reminders. Calculate the individual reminders. Calculate the individual reminders. The product of the individual remainder is also going to be the remainder for the entire product. For example, what is the remainder in this case is 1. What is the remainder here? 4. Remainder is going to be 4. What is the remainder here? 6. What is the remainder? 10. So calculate the remainder for the entire product. 240. 240. 4 into 6, 24 into 10, 240. Again 240. So I don't need to really calculate 240, which is exactly, fortunately, only one time 125. So 115. So definitely the product of individual reminders is going to be the reminder of the entire product. So without much hassle or without any efforts, we still will be able to narrow down to the right choice. You don't need to really calculate for the entire product. For example, let me give you another simple example for you. For example, look at 3 power 100 divided by 2. What is the remainder? I don't want you to calculate the value of 3 power 100. So can we express a remainder of 3 by 2? Remainder of 3 by 2. Again, remainder of 3 by 2. How many times I have to do? 100 times. 100 times. The beauty is every time I'm going to get 1, 1, 1 up to 100 times. So the remainder is going to be how much? Remainder is going to be absolutely 1. For example, let's say I've given 2 power 100 by 3. 100 by 3. What is the remainder? Now there are two ways of doing. I'm going to introduce the concept of negative remainder. Please. Converting the problem into positive remainder, which is easier to do it. So can we express this as 4 power 50 by 3? Every case, because 4 by 3, 1. 4 by 3, 1. So how many? Up to 50 times. So definitely the remainder is going to be 1. Or another way, can I say when 2 divided by 3, 3 ones are 3, which is going to be when you are subtracting. So can we express this as minus 1 whole power 50, which is absolutely going to be how much? 1. But be cautious whenever, let's say, you got the same question. Let's say you got same question. Please stay focused. Let's say I've given the question 2 power 101 by 3. Now one of the ways of doing is, can we say 2 power 2 whole power 50 into 2 power 1 divided by 3. So can we express this as 4 power 50 into 2 power 1 by 3. When you are dividing 4 with 3, this is always going to be 1. So 2 into 1. So the remainder is going to be 2. 2 into 1. Or the same question, if at all I'm thinking as a concept of negative remainder, can we say minus 1 whole power 101? When I say minus 1 whole power 101, what is that we are going to get? Minus 1. So whenever you are left over with negatives, be careful. I need to add divisor. What is the divisor here? Minus 1 plus 3, which is absolutely going to be 2. So what is the remainder here? 2. Now let me give you some more questions. So yeah, let me erase. Please stay focused for 2 more minutes. So look at, let's say I've given 58 power 99 divided by 7. If I were you, can we immediately say, because 7 8s are 56, so the remainder is going to be how much? 2. If it is 1, it is always, because every time I'm going to get a remainder of 2. I should not stop here. Now can we express this as 2 power 3 whole power 99 whole power 33? I'm sure all of you have a little difficulty in understanding. I'm giving you 1 or 2 questions in this concept, and then look at it. So please see through that. All of you are looking at. I've already broadcasted the question, so please see through that. This is the question I've broadcasted. Make sure that all of you are through that. All of you are paying an attempt without fail. In case if you don't understand, feel free to ask me. Yeah, so if you look at 2 power 82 divided by 15, all of you look at this question, it's very simple. So what is 2 power 1, 2, 2 power 2, 4, 2 power 3, 8. I need to see that somehow I'm getting a reminder 1 so that it becomes much easier. 2 power 4, 16. So can we express this as 2 power 82 as 2 power 80 into 2 power 2? Because the reason is 2 power 4 power 20 into 2 power 2. The reason is very simple, because a power m into a power n is always going to be a power m plus n. Similarly, we also know the fact a power m whole power n is equal to a power mn. As far as this question, intentionally while we are doing, because I know the fact 2 power 4 is 16, so this can be expressed as 2 power 16 power 20 divided into 2 power 2 divided by 15. Because whenever 16 is divided by 15, the remainder is always going to be 1. So this remainder is going to be definitely 1. And this still retain as 4, 2 square, because 2 square is 4. So 1 into 4, absolutely it's going to be how much? 4. Yes, I'm repeating the concepts. Let's not worry too much on that. I'm repeating the concepts as part of this question. So it's simple, the same concept. As far as this question, I'm hoping that all of you are aware. So what I'm saying, instead of calculating the product, find the remainders individually. So the remainder 126 divided by 125. Remainder 129 divided by 125. Similarly, remainder 120, 131 divided by 125. What is going to be the remainder 135 by 125? Every case, what is happening? This is remainder 1, remainder 4, remainder 6, remainder 10. So take the product of individual remainder and again divide with 125. So in this case, what is happening? 4 into 6, 24 into 10, 240 divided by 125. So what is going to be the remainder when 240 divided by 125? So keep it very simple, 125 exactly one time. So the remainder is going to be how much? 115. So that is what I've said as a part of reminders. Similarly, if you look at I've also explained, for example, 3 power 100 divided by 2. What is the remainder when 3 power 100 divided by 2? So all I'm saying, instead of taking 3 power 100, take individually 3 into 3 into 3 into 3 into 100 times. But the beauty is, every time I'm going to get a remainder 1, I'm expressing as 3 by 2, again 3 by 2, 100 times. So every time I'm going to get 1 as a remainder. The beauty is 1 into 1 into 1 up to 100 times, which is also going to be 1. So similarly, let's say I've given the question remainder 2 power 100 divided by 3. So then what you are going to do, express this as 2 square whole power 50, because I'm converting as 4 power 50, which is very easy to compute, because remainder 4 by 3 is going to be how much? 1 up to 50 times. So every time I'm going to get 1, which is going to be definitely 1 power 50, the remainder is going to be how much? 1. Now, very importantly, you also need to understand the negative concept, 2 power 100 by 3. If I were you, what I'm saying, this can also be expressed as 3 ones are 3. The remainder is going to be minus 1. I can also explain this as minus 1, remainder as minus 1. How many times? Minus 1 up to 100 times, which is also going to be 1. But more importantly, the same question, if at all I've given 2 power 101 into 3, then what will happen? Minus 1 whole power 101, you will end up getting minus 1. Whenever you are getting a negative reminders, I said add the divisor. Divisor here much 3. So the if at all I am increasing the complexity, that's what I've said, 58 power 99 divided by 7. So because 7 8 is a 56, 7 8 is a 56, remainder is going to be how much? 2. So every time I'm going to get so I'm repeating here 58 power 99